Thank you so much, team, for joining in. Now, the today's session is a very interesting and an important thing. The reason because the topic of this session, and even there will be multiple sessions will be conducted as part of this series on MLOps. See, the main topic of what we'll be doing in this series of webinar that we'll be hosting with Manifold AI Learning is make the professional to understand the MLOps technique and how you can implement it for your own projects, whether it could be your personal project or whether it could be your organization project. Because irrespective of the place that you will be implementing, the techniques that you would follow should be the same. Because whether it's for learning purpose or whether it's for implementation, you always have to practice the best practices so that you can deliver your best. Now, with that goal in mind, here as part of our learning journey, so we have decided at Manifold AI Learning to conduct this series of webinar around this topic where we'll pick up a topic. Like for example, we'll pick up a task. It can be a classification or a regression, and we'll see this in end-to-end manner. So we'll pick up a single topic. We'll try to understand what are the thought process that yours, like what is your thought process should be when you first get the data. And then once you get the data, then we'll talk about what are the pre-processing activities that you would do, which basically covers the experimentation part. So if you're someone who is new to the programming and even very new to the machine learning, you would still be able to follow, because during the session I'll be talking through in-depth manner and I'll give you the intuition. Okay, so we'll be providing you the intuition over there as well about the machine learning techniques, data pre-processing, and we will complete the experimentation. Now, once the experimentation is completed, we would go ahead and proceed with the next phase, assuming that whatever the experimentation that we have conducted, it was fruitful and we were able to get the outcome as per our expectation. Now based on that, we will proceed with the next step, that is packaging our machine learning model, and then we will go about and talk about the version control, that is working with a GitHub repository and working with continuous integration, continuous deployment, continuous training. So we will go through it one by one in detail as we progress in this learning journey. So, if you're someone who is new to machine learning or machine learning operation, or if you're someone who's just curious to know about how machine learning models will be deployed to the production environment, I would say this is the right session for you. Now, as I mentioned, this session has been made possible with the team at Manifold AI Learning. So, Manifold AI Learning is a online company which is into providing the tutorials, self-paced video tutorials on various topics of data science, artificial intelligence, machine learning, deep learning, and even the MLOps. My name is Nachiket Murthy, and I've got an opportunity to create some of the amazing courses with the team of Manifold AI Learning. So they have got some amazing courses around here. So you can check out the course. There are various courses around MLOps, LLMOps, which is in demand these days, generative AI, and we're there to help you in your mathematics for machine learning. So do check out the courses at their site, and all the courses you will get as the 30-day refund guarantee, which means if you're not satisfied with any of the courses that you purchase with them, so you'll be getting the refund with no questions asked within 30 days. So there's no hesitation for you to try out. So that's the benefit that you're going to get by registering yourself for the courses at Manifold AI Learning. And since you have joined the session with me, so there's a special coupon code that's called as webinar 10. So using the coupon code of webinar 10, you can actually get 10% off on the prices that you see on their website. Okay, so I'll be sharing the links over here for your reference so that you can have a look at it if you decide to take your learning journey to the next level, where you want to deep dive and understand in depth about how you can actually productionalize your machine learning model. Okay, so with that said, so let's come back to our today's agenda. So the agenda of today's session is to performing the implementation of the MLOps technique. So that would be the overall agenda, guys. So let's proceed ahead. See, to start with, we'll have a short introduction to MLOps. Then we'll look into the importance of end-to-end approach, and then we'll take a hands-on approach with the experimentation part. Okay, we'll take the hands-on approach with the experimentation. With that, you can actually get the hands-on approach with the experimentation path, where you would go ahead and learn about implementing the various techniques when it comes to applying the machine learning model on the given data set. Okay, so that would be the agenda, guys. Now, before we proceed ahead and before I speak about it, I want to know from you guys. So, what do you understand about MLOps? And why do you think the MLOps is actually required for any project? So, let me know over here in the chat window or through the comment section from wherever you have joined. Okay, I see some responses over here. Santrupti says MLOps is a technique where we'll be using machine learning and DevOps technique. That's a good one, Santrupti. Okay, how about others? What do you think is MLOps? Okay, so Diksha says the same, like combining the machine learning and then taking it to the further steps in the implementation. Okay, thank you, Diksha. And how about others? So, what is your knowledge level and how comfortable are you with MLOps? So, Lakshman says it's a high level way where we take care of the deployment and other stuff. Not only we stop from the deployment, but also take it from the next to the deployment. That's correct, Lakshman. That's a good understanding. And I see Piyush has responded. Piyush says that deploying the production ready model and monitor it continuously. Thank you, Piyush. Okay. And I see a few more responses. Dakshini says that the MLOps is like DevOps for the machine learning project. Excellent, guys. And thank you so much for all your responses. Like from your responses, I think at least it's clear that some of you have got some idea about what exactly is this MLOps. Now, let me just describe what exactly is this MLOps. So when we say MLOps, it's a shorthand or it's a short for machine learning operation. It's the machine learning operation. Now, what it comprises? It comprises of set of practices and the tools which is aimed to streamline as well as automate. So streamlining and automation of the machine learning models. Streamlining and automation of the life cycle of the machine learning models. So to streamline and automate it, obviously we need to have the set of processes. So MLOps will consist of the processes for developing, deployment, monitoring, and even managing the machine learning models in the production environment. So basically this MLOps, what it does is it derives the concept from DevOps. So it's like when you talk about DevOps, it's a set of practices which are aiming to improve the collaboration and the automation between software development and the IT operations teams, right? So this MLOps, it borrows the concept of DevOps. And then on top of that, it has been adjusted to suit the machine learning projects. Now, there are a lot of difference compared to the general software development and working with machine learning project. One of the key differences when you consider the machine learning project, so you'll have a lot of components. You'll be working with the data and you will be tracking the data. And let's say if there is any changes that happens in the data, you'll have to again train your machine learning model. Now, that's not the case in the case of software engineering. Now, if there are any feature getting changed, then you'll have to train the model. That means you'll have to track the data separately. And in case of software development, you will just have an application code which you will package it and deploy it. But in case of machine learning, the artifacts that you would have, It's not just the code, but also you will also have the files. It could be model data, pre-processing files, and many other things which you have to package it together so that it works in union to give the best experience. So when we talk about MLOps, it includes version control for the machine learning code and data, automation testing, validation, continuous integration, continuous deployment pipeline, and deploying the models to the production environment, monitoring, and even logging the model in in a timely manner so that we can track the model performance and detect the issues. So by implementing the MLOps practices, the overall organization can increase the efficiency, reliability, and scalability of the machine learning workflow. Now, the demand and the importance is very high. The reason because these days we have many data science team in the projects, and each and every data science team have created the best performing model on the data set. But the challenge comes is realizing the benefit of such model in a business environment. To realize that model, to realize the benefit of that model which the data scientists have created in the notebook, it should be deployed in a production environment. If it's not present, if it's not facing, or if it's not used by the customers, that's where the challenge lies in getting the more out of the data science team. So as a result, what would happen whenever there is a project cut? So company would think that since the data science team is not making any impact, they are already into the research, so they'll be the one who face the crunch whenever they want to cut the budget for the growth in the department. So to avoid it, that's the reason more and more companies are looking forward to implement the MLOps practices in their teams as well as in their organization so that they can get the most of the model that they are trying to build. And that's what we are going to understand in our learning journey as well. Okay, so now that you have learned about the MLOps, the key idea of the MLOps is, so we'll do one thing without wasting much of the time. We'll take up the data set. We'll do the same stuff as the data scientist would do in a company right now. We'll wear the hat of data scientist. We'll pick up a data set and we'll start solving the data set. That means we'll find the pattern in this data set. We'll take up some experimentation. We'll do the pre-processing, and then we would go ahead and think about the next step. So this session is all about the experimentation, where we will experiment the model and we will bring out a model which is a best performing one, which is like a satisfying for us, which we can take it to the next step. So is that okay, guys? So can we proceed with the experimentation? So please type in yes in the chat window. Thank you, Rakshit, Diksha, Samyukta, Sridhar, Shashikant, Lakshmikant. Okay. Da, uh, Nathan, KR, okay, and Damayanti, Diksha. Excellent, guys. Thank you so much, team, for confirming. Thank you, Josie, and thank you, Rajendra. Perfect, guys. So let's go ahead and let's pick up a data set. So for the benefit of time, what I've already done is I've already picked up one of the data set. So I picked up one of the binary classification data set from the Kaggle. We will load the data set using our libraries of Python. And once we load the libraries, and then we will load this data set and perform the pre-processing. So let's take it from there. I'm going to launch my Jupyter Lab, and team, all the code that I will be using right now. So it will be part of the site. Let me just share you. So all the source code that I'll be writing, it will be made available to you on the GitHub repository. That is github.com/manifold AI learning. There's a repository which has got the name as MLOps Live Manifold AI learning. This is where I'll be storing the code. Okay, this is where you can access the source code. Now, the sessions recording and whatever the slides, okay, so whatever the sessions recording and the slide, so that has been made available to you on a separate portal. Let me share you that portal link as well. So you can access the, if you go to this GitHub repository, you can actually see the complete links which I'm talking about. Let me share on the other platforms too first. Okay, I've shared over here in the chat window or the comment window. So here, this is the repository link. So all the source code are made available in this GitHub repository. Now the sessions recording and the slides are made available on this link. If you just go to the link, you can get an option of access recording and code for free. So once the session is completed, the recording will be uploaded in your portal within 24 hours. Okay, so that is how you can access the slide recordings and like session recordings as well as the slides that I will be using as we progress in the learning journey. It's not just a slide. Even if I create any notes, I'll be sharing there and I'll be uploading over there in that link. Okay, so now let's come back and let's start with our step one for today's journey, that is experimentation. So for the experimentation purpose, I have already downloaded a data set. So that data set that I have downloaded is called as, I think it's online foods data set. I've got various columns. It's an interesting data set where we have got the column of age, gender, marital status, occupation, monthly income, educational qualification, family size, and the location of that person, pin code, and we also have the information about the output, whether the person whether like it's a binary value, it says yes or no. And this output column, I think it has been already created somewhere to us based on the feedback. Okay, there are some columns right here. There is the feedback over here as well. So these are the columns that we have got. Okay, now what we'll be doing is, okay, so we would go ahead. Okay, I think this is the feedback which we have received from that customer on a specific restaurant. So we have the target column, which is output, and we also have the information about the feedback. So this is how our data would look like. Now we would use this data and apply the various transformations on this given data set. We will train the machine learning model, and once we train the machine learning model, we will take ahead with the next step. So here in this case, if you look into the type of data that we are dealing with, so the age is a column that we have got which contains the numerical values, and gender contains the categorical values. Now I've got a question for you. So from the knowledge of statistics, so what is the type of column that this gender is? Whether it is a nominal data or whether this column gender is an ordinal data. So what do you think, guys? That's one of the most commonly asked question in interview as well. So what do you think? What type of data is this? So so the question is whether this is a nominal or ordinal. Okay, the question is whether this is a nominal data or a categorical data. So BS says it's a categorical. Okay, PU says it's a nominal. Okay, how about others? What do you think? Is this a nominal data or an ordinal data? Okay, Josie says it's a nominal. How about others? What do you think? Is nominal is correct? Okay, BS says now it says as nominal. Okay, perfect, guys. So, as most of you have mentioned, yes, this is a nominal data. So, if I want to give you a background, so nominal data is a type of a data where it's just the collection of labels. There is no ordering present. That kind of data, we call it as a nominal data. Okay. Then, when it comes to ordinal data, that's a kind of a data where there is some kind of ordering is present. Similarly, we've got marital status, the occupation, the monthly income, and the educational qualification, the family size. Okay, and we have the information about the location. We can actually use this information and try to locate the area name in case if you want to do the further pre-processing and then further categorize it. It is like an optional pre-processing activity which you can think about to enrich the data set. So we will not focus much on enrichment as of now, but if you're someone who wants to take to the next level, maybe you can also think about perform the data enrichment as well. Like, to give you a hint, using the latitude, longitude, and pin code. So trying to triangulate the area name. Okay, so it looks like this area name looks to be from the Bangalore location. So try to get the area name using the various APIs that are available. It can be from Google or any other map related APIs, and get the area name and populate those area name. And once you populate the area name, maybe try to categorize it, whether it is East Bangalore, West Bangalore, South Bangalore, or North Bangalore, and then try to check, okay, whether you can see any patterns in the data set. You can use that as an additional activity in case if you want to take the data like what we can say data enrichment to the next step. And we have a feedback which says positive or negative. That's what we see right here. Okay, that's how our data set would look like. So let me go ahead and start by creating a new notebook. So I'll start by creating a new notebook. Okay, so here I'll say experiment.ipynb. So obviously we'll start by loading the necessary libraries. So we can start by importing the necessary libraries, like import pandas as pd and import matplotlib.pyplot as plt. And I'll also import the numpy library in case if I would require. So this will load the necessary libraries, and then we'll start by loading this data as a data frame. So pd.read underscore csv, and we'll specify the file name, that is onlinefoods.csv. Now we will display first few entries of this data frame. So this is how our first few entries of this data frame would look like. I've got various column: age, gender, marital status, occupation, monthly income, and so on and so forth. So this is how the data set would look like. Now we have got a column which is like the unwanted column. It says as unnamed 12, and it looks like it is very much same as the column of the output. So we can simply go ahead and drop this column. Now, if I want to drop the column, so how can I drop a column? Can anyone tell me? So what method can I use it to drop this column from the data frame? Yes, that's correct, Lakshmi. How about others? Dheeraj, yes. Uh, okay, Rajitesh, yes. How do I drop this column? Yes, as that's correct, Samiksha. So as most of you have mentioned, if I want to drop any column, yes, I can just make use of the drop method. So df.drop, and I'll say, okay, remove this columns of unnamed 12. That's the column that I want to drop. Okay, this is going to drop that column. Now I want to save in place. So I'll say in place is equal to true. It's a basic operation of pandas data frame. So this would go ahead and drop the column. So now that we have dropped the column, now we are left with other columns that we have got. Now, as I mentioned, usage of latitude, longitude, and the pin code. Okay. So usage of latitude, longitude, and pin code. It's like it's a data in, I would say, data enrichment task. So we'll not do the data enrichment. So what we will do is we'll just go ahead and drop these columns like latitude, longitude, and pin code. So we'll follow the same steps like we did earlier. So I'll say columns, and I'll say latitude, longitude, and we'll also remove this pin code. Okay, so I'm now dropping all these three columns from this given data set. Now we are left with the required columns like age, gender, marital status, occupation, monthly income, educational qualification, and so on. Now we'll just go ahead and look into the uh, interesting facts about our data set by describing this data frame. So in order to understand about our data frame, so we'll just say df.describe. So this would go ahead and describe the numerical columns in our data set. So there are only two numerical columns in this data set. So here we've got the age column, and now apart from age, we also have the family size. Okay, it says that okay, in total I've got 388 rows, and the mean age, that is the average age in this given data set, is 24.62. Okay, so that's the overall average age that I've got. Now average age will not let us know the complete detail about our data set, so we'll also have to refer to the other statistical properties like the minimum and the maximum value that let us know about the range in which the values are spread out. So the minimum value is 18 and the maximum value is 23. Okay, that's a good range, I would say, because there are like the range is not so big, I would say, by simply looking into this minimum and the maximum. And if you look into the median, okay, interestingly, the median over here is actually closer to the mean. Now, what does it mean? Like, what do you concur when the mean value in a given column is similar to the median? So, what do you concur from this given data set? So, what do you make out, guys, when you look into these kind of properties on the data set? Okay, that's correct, Darshan, Diksha, correct, Josie. Okay, and how about others? What do you think? Okay. The KR, that's correct. So as most of you have mentioned, so whenever I've got the value of a median or mean when they are actually closer together, that's a scenario where we will say that the data that we have got, it is normally distributed. So it's a good thing that the numerical column that we have got, at least by looking at the mean and the median value, we can see that the data is actually distributed normally. And if we observe the family size, even we observe the same thing. I mean, minimum is 1, maximum is 6, and the median is 3, and the average is 3.28, which means the values are closer, which means it's a normally distributed data. So which is a good thing for us, which makes it simple for us when we want to apply any model, because we are already satisfying one of the core property of very simple models like the linear regression. Okay, that's what we can make out by analyzing the numerical column. And we can also look into the q1 and q3. Maybe we can use this q1 and q3 directly in the box plot to identify the outliers. We don't have to do any analysis as of now. Now we would go ahead and look into the uh, categorical column as well by mentioning as include is equal to O. So this is going to return the information about the categorical data too. See, if you look into the data.describe output for the categorical data, we can see that even in all these column we have got 388 rows, which means overall in the data set in one way we have validated that we do not have any missing values. And the gender column has got two unique columns, and the thing is out of 388 I've got 222 rows which are male, which means it's a kind of an imbalance that we see in the gender column. And when we look into the marital status, it looks like the most of the data that I've got, it is where the people are single. Out of 388, 268 folks are actually single. Okay, it could be a reason because see the range in which that I would observe is 33 to 18. So maybe because of that reason, for the region that I have collected, maybe most of them are unmarried people. That is the reason marital status is single. And the occupation is student. That's the top highest value, which has got 207 rows. And out of 388, 187 people do not have any income. And there are, I would say, 5 unique values in the educational qualification, and graduate is the one which is a top one. And when it comes to output, even this looks to be an imbalance. We have more number of rows where the output is yes. Okay, that's what we would observe. We'll keep that in mind. And we also have the information about the feedback, which says as whether it's positive or not. Okay, this is what we would observe over here on this given data set. Now, in all these examples, okay, so most of the column that we see right here, okay, most of the column that we see right here, so like it's all the categorical data. So one way that would be suitable for this given data setters is to implement the data transformation technique, where we can go ahead and convert this categorical data into a numerical format. And one technique that I can use it is one hot encoder technique, where we can encode the given data set into ones and zeros. So that's the idea about this one hot encoder. To give you an illustration as how it actually works, suppose this is a column of the marital status. Okay, I have the values like married, single, 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 and married. Suppose if I have the values in that column in this manner, then what it says is when you say one hot encoding, we'll extract the unique values of this column. Okay, we will extract the unique values of this column. So the unique values are married and single. Then we will try to represent each value over here in terms of a vector, where the vector size is equal to the number of unique values. Here, married is 1, single is 0. Single is 1, married is 0. So in this way, we'll try to represent it in the format of zeros and 1. And we call this technique as a one hot encoding technique, where we would go ahead and find the unique values of the given column, and then we would go ahead and transform the given data set. So that's what we are going to do right now. So let's go ahead and apply the one hot encoder for this given data set. Now, before I apply this one hot encoder for this given data set, yes, importantly, I need the column names, right? So I'll just say dot columns. This will return the column names for my one hot columns. So this will get me the list of columns that we have got. Okay. Now, once I have this list of columns, now we can go ahead and apply the one hot encoder on this given data set. So I'll say from sklearn dot preprocessing, I'm going to import the one hot encoder. Now let me take you to the documentation page of this one hot encoder. So this is the official documentation page of this one hot encoder. So what it does is it will help me to encode the categorical features as a one hot numeric array. So that's what this is going to help me to do. Now, the way that we do it is we'll import the one hot encoder. Then we will go ahead and initialize the object. And then once we initialize the object, we will make use of a method. If I come down in the official documentation page, it describes the method that we can apply. So we've got a fit method. We use this to fit the one hot encoder for the given data, and then to transform the given data. So we will make use of transform. Okay, so that is what is expected, guys. So it is expected that we mention it in this format. So let's go ahead and apply it on the given data set. So I'll just say OHE is equal to one hot encoder. Now I'm going to say one hot encoder dot fit my original data frame, And here I'll just select the one hot encoded columns. I'll perform the fit on this one hot encoded columns. So this will perform the one hot encoding on the categorical columns that we have just selected. Now, once this object has been created, we can look into its various properties. Like for example, I can say get feature names out. It will return the various feature names that it has selected. So what it has done is, I'll show you. Okay. So let me just say, so let me just select one column. Okay. From there, you'll get an idea. Suppose you'll select, if I select the column of gender, see the unique values are female. So we'll create a for loop so that you can see it right here for C in one hot encoded columns. So we will say this as the unique values are unique values of column C. We'll say in that manner. So now we can check. See, the unique values in the gender column are female and male. The marital status are single, married, prefer not to say. And unique values of column occupation are student, employee, self-employed, housewife, and the monthly income. Okay, and unique values of educational qualification. So these are the unique values that we have got in each column. So what it has done is it has identified these unique values. Like let's consider the column of gender. If you look into this column of gender, so we can see that for the gender column we have got two values, female and male. So what it has done is it has added the prefix of the original column name underscore the unique value female and male. So this is how we can get the features. Now why is this get feature names out is important for us? Well, once we transform the given data set, at that time during the transformation, okay, we will have the challenge, like we'll have a challenge where uh, like it will be an array format, so it will be very difficult for us to pre-process it. So the easiest method is to go ahead and get this feature names out and create it as a data frame. So that would be a technique or an approach that we are going to do. So now that we have this feature names got it, that means we have identified the unique features in each column. Let's go ahead and transform it. So I'll say one hot encoder dot transform, and I can just mention the uh, selection. So now what it has done is it has generated the output, which is an one hot encoded output, and it has generated the output in the format of a sparse matrix. Now, sparse matrix is a special type of matrix where we have most of the elements are equal to 0 and only some of them are equal to 1 or a valid value. That's when we call the matrix as a sparse matrix. So if I want to convert it back into a dense matrix, I can say too dense. So this will go ahead and convert it into a dense matrix. Now what I can do is I'll say df transform is equal to pd dot data frame. We'll mention the students as a data, and for the columns, okay, I can go ahead and mention this columns that I have extracted earlier. So this is how the one hot encoded data would look like. Now I've got a question for you guys. Okay, so I was expecting that someone would ask, but I'm asking this question to you now. Now if I want to create this one hot encodings for a given data, so we've got an other method that's called as get dummies method. So we have the pd.getDummies method to generate this one hot encoded data representation. It's very much simple also. But why have I not used it? What could be the reason, according to you, that the benefit that we are going to get when I'm making use of this one hot encoder object instead of the pd.getDummies? So can anyone tell me? So what do you think, guys? Okay, let me answer it for you. See, if I make use of getDummies, it will perform the transformation based on my existing data. Whatever the data that I have got, based on that, it will perform the one hot encoding. Now, if I make use of one hot encoder, I can save it as a object with me, object file, and use the same transformer in the other environment. Currently, assuming that it's in the experimentation phase, maybe when I move to the development environment or in the staging environment, even in such scenarios also, I can make use of the same object and perform the operation or the transformation over there. So that would be a benefit that I'll have if I make use of this one hot encoder. Okay, so that is one of the reasons that I made use of one hot encoder instead of pd.getDummies. Now, once I have this data frame, so next what I'll do is I would go ahead and like concatenate my data set. I'll say pd.concat. So I'll concatenate my df.transform, df underscore transform with my data frame, but here in my original data frame, okay, I'll be interested in selecting only the numerical column, that is age and the families, age and the family size. So I'll say age and family size. So this will perform the concatenation. Okay, so this has performed the concatenation. What I have done is I have added the column over here, that is feedback positive, and this one over here, and did the same thing. But there seems to be another challenge that we have come across. One is the output column. See, the output column has, like, on top of that we have performed the one hot encoding. Let's just fix that. So before I apply this one hot encoding, so what I'll do is I'll separate my target. I'll say df and we'll get the output column. Then we'll say df dot drop columns is equal to output in place is equal to true. So this will remove my output column. See, once we drop that column, I think now we just, this data frame contains only the features. Okay, now let's apply the one hot encoding again. Now once we drop this, we'll have to remove this code here. Let's see, yeah, we'll have to remove this code and place it here. So in this way, uh, we can actually perform the one hot encoding. Okay, now this has been taken care. Now let's go ahead and get the same guys. Okay, now if we look into the data frame dot head, see, this is my original data frame. Now after the concatenation, so we have the data where it contains the values which we want. So we have prepared the data, and this is my data set. This df contains all the values in a numerical format. and the age and family size follows the normal distribution. And we have another variable, let me just call it as df underscore final. Okay, so this is my df final, which is nothing but our features final that I've got. We'll use this features file that we have got and use it in application of the machine learning. So as I mentioned, you can also go ahead and proceed with the visualization before you perform the one hot encoding. To give you an illustration, let's suppose, okay, so how does the overall feedback would look like depending on the education qualification, or depending on the marital status. So what kind of output that we are getting. So if you want to analyze those kind of activity, definitely we can make use of seaborn library or matplotlib library to create the visualization for this given data set. Okay, you can actually feel free to do it. So since our learning journey is specifically to the MLOps, I'll just skip through the part. Okay, so I'll just skip through the part right here. uh, 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 okay, so I'll just a second, folks. Okay, now we'll just skip through that part of data visualization. You can feel free to continue with implementation of the same. Okay, and I've got one more question right here. So we saw a few columns are biased and imbalanced. So are we good with creation of the model? So we are going to create it as of now of KR, because it will be like we'll be derailing from our agenda, because we are currently interested in the implementation and making the machine learning pipeline operational. So it is definitely a good observation, I would say, KR, because there are some imbalances. We'll have to try to get some more data, maybe try to collect more data set from outside from the business. Since that's not the case, since it's a data set that we got from Kaggle, so we'll just proceed with the existing data that we have got. Okay, guys, so we have got the data set. We have performed the operation of pre-processing on this data set. Now let's go ahead and take up the next step. So we have already splitted the data set into two parts, that is X and Y, that is DF and target. Okay, that is also has been done for us. Now the next step that we are going to do is we are going to train our machine learning model. Now once we train the machine learning model, we would go ahead and perform the next steps, that is saving the model file and the other stuff. Okay, so let's go ahead and split this data set into two parts. So I'll say from sklearn dot model underscore selection will import the train test split, and then I'll say xtrain comma xtest, ytrain comma ytest, train test split. I'll mention my x and y, test size as 0.2, and maybe I'll mention my random state as 6. Okay, just to have the same. Okay, it's not x and y, it's actually df and target. So this will split the data into two parts. I'm just splitting the data in the ratio of the 80/20. So that's what I'm going to do right now. Okay, next, once we split the data, so next we would go ahead and implement the model. So for demonstration purpose, we would go ahead and implement some of the most commonly used model, since it's a classifier. So we'll make use of logistic regression, we'll make use of dysentery, we'll make use of, let's say, random forest, we'll make use of the SVC. Okay, so we'll implement all this, whichever is the model that is working fine, we'll choose the one. Okay, that's what we'll be doing. We'll not dive deep into the hyperparameter tuning too, but we'll touch base upon those steps as well. First, let me just go ahead and import the necessary model from sklearn dot linear underscore model. We'll import our logistic regression. Okay, then from sklearn dot tree, we'll import dysentery classifier, since it's a classifier activity that we are doing. Then from sklearn dot uh, Let's assume, yeah, uh, SVM. I'll be importing SVC. Okay, now if you're someone who's not aware of the SVC, do check out the yesterday's webinar that we have conducted. There was a webinar that was conducted in the YouTube channel and our platform, social platforms on Manifold AI Learning, where we have talked about the implementation and the intuition behind this support vector machine. I'm just sharing the link over here. You can bookmark this link and you can refer to it at a later point where we have talked about the support vector machines in detail. Okay, so we'll import the support vector machines, and from sklearn dot ensemble we'll import the random forest classifier. Okay, once we import the models, we would go ahead and initialize the model. I'll say logistic regression. We'll just uh, implement a, a default model, and then we'll perform some hyperparameter tuning. This addition tree classifier and SVC. I'll say SVC. Okay, then random forest classifier. Okay, so we can also mention the hyperparameters. For now, I'm just going to initialize it with some values that we have got. Now, since it's a classifier, and we'll make use of one of the metric that's called as the F1 score, because I want to make use of the model which is a balanced one. Like it should neither be showing the false positives, and it should neither be showing the false negatives more. So I want to have a balanced model. So hence the evaluation metric that I would choose it is the F1 score. So we would go ahead and create a for loop. Maybe I'll just say models is equal to, we'll add everything over here, log addition tree SVC random forest. Okay, now what I'll do is for in models, I'll create a for loop, and for each model I'll perform the fit on my data set, xtrain comma ytrain. Then once the fit is completed, we would go ahead and generate the prediction. So I'll say m dot predict. We'll specify our xtrain. Okay. Now, since we want to use the F1 score, I'll say from sklearn dot metrics, I'm going to import the F1 score. And remember that we can calculate this F1 score, and this is one of the most used evaluation metric. Okay, so that's the reason that we are importing this F1 score. And once we have got the prediction, so I'll just say F1 score will create one thing. Okay, we'll create the uh, Python dictionary, and I would mention in this manner. Okay, so yeah, for now, let me just keep it as list only. That's enough for us. Okay, so I'll say scores dot append, and we'll get the F1 score, and we would send in our ypred comma ytest. So actually it should be xtest, guys. Okay, let's just validate it once again. F1 score sklearn. So here we'll have to specify the y true and y pred. So it means it's the other way around. So it's y test comma y pred. Okay, we'll calculate the F1 score, and once that is done, I'll just display the source scores. Okay, we are seeing some error, could not convert string to the float. Now this, let's check why are we getting that issue. Because okay, the reason that we are getting this issue because we are not sending in the data that we had prepared after the concatenation. Df final has to be sent here while performing the split. So let's go ahead and get the target. See, the target is yes, no. So let me do one thing. Let's apply the mapping over here. Okay. So it's better we map this as well. So I'll say target dot map, and I'll say for yes, map it to 1. For no, I'll map it to 0. Okay, so I've done the mapping. So now I think it should resolve. So we've got the output, guys. So the good thing is we've got the output and we can see the results. So we can see that the first model is 0.90, second model is 0.86, third is 0.8, fourth is 0.91. Let's check the first and last. First one was logistic regression and the last one was random forest classifier. So we've got two models which is actually performing best. So out of these two models, so let's do one thing. Let's try to keep it simple. So let's make use of our logistic regression model as the final model that we want to use it. Now the reason, because one, this logistic regression model is simple to explain. So if I'm making use of this logistic regression model, I can check the what are the coefficients. Okay, and from this coefficients I can get to know which feature how much importance that I'm actually giving. At least from the numerical value we can try to get an intuition behind what is happening in that model. Okay, so that's what we have displayed right here. And also you can also get the intercept too for this logistic regression model. So we can make use of this model. So one advantage is it is simple, and the another advantage that we have, okay, the another advantage that we have got is it is easy to explain. So hence let's say that we'll make use of this logistic regression model is the one that we'll be using it for our further activity in our MLOps journey. Now the common question that comes to us is, okay, I've done the setup as a data scientist, we have fit the data set and I've got the model and I've decided that logistic regression model is the one that I want to use it. Now the question is, how do I move this model from my current system to the new system, let's say staging environment or a production environment or in the other environment? Well, first thing that you need to remember when you are working with the machine learning models is serialization and the deserialization. Now, when I say serialization, it's basically converting the model file into a binary file format which can be saved into a memory. So deserialization is nothing but reading that file, binary file, and creating it as a variable so that we can generate the prediction. So in order to perform this serialization and deserialization, there are various options that are available for us. Now, one common method that we generally use is making use of a module that's called as joblib. So in order to save the model file into an external file, we'll import the joblib library. And I would say joblib.dump, and I'll mention the file that I want to like download it. That is the variable which contains the data. I'll say logistic regression, and I'll say this is my trained model. And we can mention our own model extension. Maybe I'll just say it as pkl. Okay, that's a pickle file. Okay, it's up to you, so how you want to name it. Now apart from this model, I'm going to save another thing that's called as one hot encoder object. So I'll be using this one hot encoder object even in the later system as well, in order to generate, okay, in order to go ahead and generate the transform data, because in the production environment I will be getting the information in this manner itself. Like when a new data is coming, I'll receive the data as female, marital status as single, occupation as student, and I'll be receiving this data. So we should be writing a code such a way that we make use of the one hot encoder that we have used it for our training and transform it on the fly during the prediction. So that is the only way that you would ensure that the model that you have trained and the model that is in the other system would work in sync, because all of them will be based on the same properties. Okay, so that's the overall intuition that you need to remember, and that's what we will be doing it as we progress in our upcoming learning journey, guys. So what we have seen as part of our today's session on the first step in our MLOps journey is the experimentation, the simple plain experimentation that we do as a data scientist, where we load the data set, load it into a data frame, perform the pre-processing, perform the fit on the data set, and then we would go ahead and generate the prediction and finally decide the model which is best for us. So optionally, you can also take care of the hyperparameter tuning and try to improve the further model as well. So in this example, we have just skipped it, but you can feel free to go ahead and do that as well. Okay, and lastly, what we did is we have seen as how we can save the model into an external file. So we have saved the model, we have saved uh, like the one hot encoder as well. So we'll be requiring both of these files in our learning journey as well during the implementation. So that's what we did right here, guys, as part of our today's session. So folks, before we proceed ahead, so are you clear with the concepts that we have discussed in this live session? So if yes, please confirm by typing as all good. If you have got any question, please do let me know. So I see a question from Josie. What about splitting the data set into training and testing, transforming test? Okay. So here, Josie, so since we were dealing with the categorical data, so we just applied the one hot encoder directly on the entire data set. So the alternative way is like we can split the data set first and then apply the fit and transform on the training data set and perform the transformation on the test data. So that can also be done. So since it's a data set for which contains all the categorical data and no other numerical values, we just use this approach. Okay, any other questions, team? Okay, now there's a question right here. The question says that can you explain how does this one hot encoder.pkl, how we use it in the production environment or on the new data? That's a good question, BS. So in order to describe it, we have a separate dedicated session that is in the next session where we will focus and understand how to make use of this model artifacts and how do we structure our entire machine learning project as a different module, and we'll also see how we can create our own package itself which we can move around in the various environment where we will maintain the dependencies of the environment that we are currently working, and we'll try to replicate it in that environment, and then we would proceed with the further step. So we will be discussing in detail in our further session in this MLOps series, BS. And any other questions, team? And there's one more question about the coefficient and the intercept. How do we interpret it? So here, okay, the another question that I see here is, okay, how do we understand coefficient and intercept values? So this coefficient values and the intercept, so they basically describe the relationship between each feature. Okay, so this coefficient, it describes the strength and the direction of the relationship between my feature that I have got and the logarithm of the odds of the dependent variable. Okay, the intercept is basically a constant. So it's the value of the logarithm of odds when all the independent variables are set to zero. That's what you would see it in the textbook. So it's basically the value which represents the baseline probability of a dependent variable being in one of the categories. So that's how we interpret the coefficient and the intercept. Okay, so guys, I think With this, I don't see any other questions right here. So with this, we come to the end of today's session, guys. Now, I would like to know from you, did you find this webinar helpful, or do you have any feedback as what we can do it to improvise it? So please let me know, folks. Okay, if you have found the webinar helpful, my request is please share it with your community and your friends so that maximum people can benefit from the various webinar sessions that are being conducted by Manifold AI Learning. Okay, thank you so much again, guys. Now, as I mentioned earlier, so do check out the courses from Manifold AI Learning. So if you have liked my teaching, I'm sure you're going to enjoy the courses that we have got on the Manifold AI Learning site. So do check out the courses from the Manifold AI Learning on MLOps, and there are other courses as well, which is about the generative AI mastery course, which is there for you to master your generative AI journey, which is a package of multiple courses. Do check out the same, and I hope you find it helpful. If you have got any feedback, please feel free to let me know over here in the questions or in the chat window. I'll do my best to answer any of the queries that you might have. Okay. So Virendra says, I'm planning to buy this. I will learn. Okay. Thank you so much, Virendra. I'm happy to know. I look forward to seeing you. Okay. Thank you, Josie. And then when will be the next workshop? So we are planning in the next week, KR. So please follow the Manifold AI Learning on LinkedIn, and also reach me on the reach me. That's any like reach me, follow me on the LinkedIn as well. I'll be sharing my LinkedIn ID. So please stay in touch. So whenever there's a new webinar that we are hosting, you get the alerts. Okay. Any other questions, team? So thanks again, everyone, for joining in on this live session on MLOps live workshop. So it has been an amazing experience to host each of you guys. We've got a lot of people dialing in on this webinar, even though it's on the weekend. So I appreciate you taking your time and joining in. So if you have got any feedback, please drop us the feedback at the rate support at the rate manifoldailearning.in, or you can let me know as well in the chat window in case if you want to speak, if you have joined through the webinar call. So let me know, I can unmute you as well so that I can resolve any of the queries that you might have. So thanks again, guys, and I hope to see you on the next webinar. Take care. Okay, there is one question from Rakshit. So how can I access the session recording? Okay, so I'll be sharing, I think you'll get an email once the session is completed. And just to confirm you again, so you can go to the Manifold AI Learning. So under this, click on courses. If you come below, so there's a course on MLOps Project Live End-to-End Workshop. You can access the source code as well as the video recording over here. Okay, thanks all everyone. Take care.